So in this tutorial, we are going to implement the binary search tree. And in the previous tutorial, we have already discussed about the rule that the binary search tree is following. We have seen that the binary search tree is a particular type of a binary tree, and I have already drawn an example of a binary search tree here, and we are going to implement this using C++. So you can see that the elements, or you can say the data in these nodes, are they are following a particular rule, a specific rule. And the rule is that the data of the left node will always be less than the root node. So if you consider this one as the root node, then the left node will have value less than this node. So you can see here it is following this rule, and the right node will have value greater than this root node. So it should have greater, and in this case it will be less than. So if you take any particular node, let's suppose you take this node, the left node will have value less than the root, and the right one will have value greater than the root. So in this way we are going to implement this binary search tree. So the first step in writing the binary search tree is that we will create a structure node that will have a key. We will create a structure node which will have data, or we are going to represent it as key, and it will have a left and a right pointer. And these pointers are basically the structure pointers because they are pointing to another node. They will point to some other node. So let's implement it. So first of all, we are quickly write all the libraries, the header files here. So first thing that we are going to do is we are going to create a structure node, and we know that it will have three values. One is the key, another one is it is a pointer, right, and similarly we are going to create another node pointer which is left. So you can see here that we have created a node which has key and left and right pointer. In the main function we are going to create another pointer which is pointing to the root node, and initially we will initialize it as null because initially our binary tree is empty. So this is our first step. The next step is to write a insert function. So we will write an insert function, and this insert function is used to insert the node at a particular position in this binary search tree. So we know that the first call of this insert function will be pointing to the root node. So we will call some insert functions, and we will pass the root node, or we will say the pointer to the root node, so that we can traverse along this binary tree, or I should say binary search tree, and we will be able to add some particular value at a particular position. So let's make some calls of this insert function, and we know that the first call of the insert function, let's insert 50 in our binary tree. So we know that the first element 50 will be inserted and it will be equal to the root. So our insert function will have return type struct node pointer, because root is also having this struct node pointer. So we are going to write struct node pointer insert function, and our insert function is taking two values, which is struct node pointer, let's suppose we take it as n, and then the second value is the key itself, and we will write the implementation of the insert function here, and it will return n, and n is our pointer to this root node. So it will just return it, and since the first call will be in the 50 value will be inserted in the binary tree, and we will just initialize it as root. So let's make some further calls of the insert statement. So let's suppose I will add 30, and similarly we are going to insert some more values like 20. I'm just going to change these values 40, 70, 60 and 80. So these are just the function calls to the insert function, and you can see that after these calls we will obtain this type of a search tree. So let's see how we will implement this insert function. So the insert function will first check whether the value of the node that is passed at the time of function call, which is the root node, is not null. So if the tree is empty, I'm going to write the first case here, which says that if our tree is empty, then we are going to return a new node. And we know that when our tree will be empty, we will just return a new node, and we are going to create a function with the name new node, which will allocate a new node by using the malloc function, and it will return a pointer to it. So this is the first condition, which says that if the tree is empty, we will return a new node. So the second step in writing this insert function is we will check whether the value of the node that we want to insert is greater than or less than equal to or less than this root value. So let's suppose I am making a functional call like this: insert root comma 30. So at this point we know that 30 is key, so key is equals to 30. So first we will check whether this value is less than the root value. So we will just check that the value, and we will use the if statement for this purpose. So we will check if the value of the key is less than the value that is passed using this function call, and we know that it is stored in the n, which you can see here in this. You can see that this is our n, So we will check whether this node's key is less than or greater than. So first we will check whether the key, which is 30, is less than the node's key, which is the root's key. And we know that this root's key is having the value 50 and the value of key is 30. So if this condition will evaluate to be true, so let's suppose it evaluates to true, so this block of statement the program will go inside this block of statement. So next thing that we need to do is we are just going to assign the left pointer of this node, of this root node, and we will use recursion like this. And the second will be the parameter, second will be key. So you can see here that inside this insert function we are again calling this insert function, but this time we are passing a different argument here, and this is known as recursion. So this is a particular example of a recursion. So recursion is exactly it looks like this. For example, you have a function, suppose it is insert, and it is having some parameters here. So if you're calling this function, this same function insert inside this function, but with some different value, which you can see here that here it is a different value. So this function will call itself again and again, and this condition is known as recursion. So when we will call this, when we will write this line, this insert function will call itself, and the value of this root node will change to this one, because in this case it is the left, it will just point to the left of the n. So we know that initially n is pointing to 250, which is the root node. So after this condition evaluates to be true, we are just going to call this insert function, and now this insert function will work on this part, or you can say in this subtree, and it will call itself again and again until and unless this condition evaluates to be false. So it will call this function with the left pointer, and it will insert it at the specific position, and if the tree is empty, it will just return a new node, and it will insert it into in this binary tree, in this binary search tree. So let's write this insert function, and the third condition will also be the same. We're just going to change the signs. So if the value of the key is greater than the root value, this time since we are going to insert it into the right subtree, we will call the insert function with the right node. So we are going to assign the right pointer and we will call this recursive method insert on the right subtree, and we will also provide it with the key. So this function will now work on this tree, and this is how we are going to do the traversal. This is recur along binary tree. So this is how we recur down the binary tree, and we use recursion, and we will call the same function again and again, and we will just change the pointer. First it is pointing to here, and then in the next call it will point to the left node or the right node. It depends upon this condition. So let's implement this insert function in our IDE. So first we will check whether our tree is empty or not. So if our tree is empty, return a new node. So in this case we will write the if statement. So if the value of node will be equal to null, this means that our tree is empty, because if root is equals to null, our tree is empty. So we are going to return a new node, and for that we will just create a function new node, and we will provide this function the key that we want to insert in the new node. So let's implement this function new node, and since this new node will return a pointer to another structure, we are just the return type will be struct node pointer, and let's suppose we are going to store the value of key in X. And so the first thing that we are going to do is we will create a temporary node. So we will create a temporary node temp, and we will assign this temporary node in the memory, and we know that we will do this using the malloc function, which is the memory allocation function. So this is how we will just allocate our temporary node inside the memory, and now we will have to assign the key to this temporary node, and we know that it is X, and we will assign the left pointer and the right pointer as null. So this function will return a node which has a value key, and the left and right pointers are null, and it will return this temporary node here. So this is how our new node function will look like, and it will work only if our tree is empty. So the second thing that we will have to do here is to write our first check statement. So if our tree is not empty, we are just going to recur down the tree. Recur down the tree, and we know that we will use recursion with combination with the if statement, and we know that inside the if statement we will check the value of key is less than the value of node's key, and if it is less than, then we know that we will have to insert it on the left side of the node. So we will change the node of left, which will point to the left of the left node, or you can say to the left subtree, and it will just call it will just make a recursive call by calling itself using a different parameter, which is node left, and with another parameter key. So you can see here that we have just used recursion This is a recursive method which will just recur down the tree and it will go to the left subtree. So I should write here recur left down the tree. So this insert function will just pass the left pointer to the n. So n will get changed from this position and now n will point here, and after again this function will be called, it will again pass the left pointer, and so the value of n will be changed, and it is not going to assign the new node in this binary tree until and unless the value of n is null. So until and unless the value of n is equals to null, it is not going to assign a new node. So it will first traverse down the tree. In our case, it will traverse left down the tree, and when the value of n will be null, and it will become null at the leaf node, so it will just insert, it will just call this new node function and it will insert the node at this position. So let's now write another case. So it should be n. We have made a mistake here because n is the node which we are passing here. So now we are going to write another case which will recur right down the tree. And we know that the condition should be the opposite. If the value of the key is greater than the right value, the key value of the node, then we will just recur right down the tree. This time we are going to create insert. This is a recursive call of the insert function, and we are just going to traverse along the right subtree. So in this manner we are going to recur right down the tree if the value of key is greater than the value of the node, and after every call of the insert function, the value of the node or the pointer node n will just change to the right values in this case, and in this case, in this one, the value of n will just point to the left part, and these recursive calls will just recur left down the tree, and when the value of the n will be null, you can see here that the n will go to the left side or the right side, and at some point it will point to the leaf node, and at some point the value of n will be null, and at that point when the value of n will be null, we are just going to call this new node function and it will assign our node to the binary tree. So in this way we have inserted the values in a particular order. We have followed the rule, and this is the rule. So now we have done the first step. In the next step we are going to do the traversal, and we have discussed about 3 types of traversal in the previous video, and these are the in-order traversal and the pre-order traversal and the post-order traversal. So we have discussed about these traversal, and these types of traversal are known as depth first traversals And the reason why they are known as depth first, because they are just going to work from the depth of the tree. So they're going to traverse like this. It will first display this one and then it will go up of the tree. So they are the depth first traversals. So in this tutorial we are just going to discuss about the in order traversal, which says that first we will just display the left node, then we will display the root node, and then we are going to display the right node. So in this case, in order traversal, so let's see what will be the output in case of the in order traversal. So in case of in order traversal, we will first have to display the left node. So in this particular example, we are just going to traverse along this tree in the left order and we will just reach this one. So first of all, we will display the left node, or you should say the leftmost node. Then we will display the root node, which you can see 30 is the root node. So next we will display 30. Then we will display the right node. So then we are going to display 40. So someone can ask, like, why are we not doing the same rule in this case? Why not we displaying 60, then 70 and then 80? Then the answer is that first we will have to follow the left subtree. So you will have to follow the left part first. After traversing the left part, you will have to go to the root node, and then you will have to come back at the right node and then follow this rule. So first we will display 20, then we will display the root node, which is 30, then we will display the right node. And now when the left subtree is over, we are going to display the root, and the root is 50. Then we are going to go to the right node, or you can say this right subtree. So this is the right subtree and this is the left subtree. So in case of in order traversal, we are just going to follow this rule: left, root and right. So first we will recur in the left part of the subtree and we will display the left node, then the root and then the right node. After traversing this left subtree, we will go to the root node, we will display it, and then we will go to the right subtree and then we will follow the rule again. First we will display the left subtree, which is 60. Then we will display the root node, which is 70, and then again we are going to display the right node, which is 80. So you can see that in the case of in order traversal of a binary search tree, we are getting a sorted result. You can see that these values are sorted in the increasing order: 20, 30, 40, 50, 60, 70, 80. And that's the main reason why we are discussing in order traversal. Pre-order and post-order traversals will have just similar implementation. We just have to shuffle the 3 lines. So let's implement the in order traversal and let's see how we are going to traverse along this binary search tree. So we know that in the in order traversal, we will first have to traverse, or we will have to recur the left part of the tree. So for that purpose, we are going to do a recursive call, and after every recursive call, we are going to make this pointer root point to the left node. Then we are going to display the root node. Then we will display the value of the root node. And finally, we are going to traverse along this right subtree. So we will create a recursive call of the same in-order function, and this function in order will just now recur along the right subtree. So this is how our in order function will look like. So first we will just traverse along the left part of the subtree by calling this recursive function in order root left. So it will just go to the left part again and again, and then it will just display the key, or you should say the data of the node, of the root node, and then it will just recur along the right tree, and it will display the right all the nodes in this specific order. So in this way we have implemented the in order. So let's write it in our IDE. So in the in order function call, we are just going to pass the root node. So let's now create the in order function. Since it is not returning anything, it is void. And now we are going to write a check statement which says that the value of root should not be null, because you cannot traverse along a tree if the value of the root is equal to null. In that case, we will just, if the value of the root will be null, we will just stop the recursive calls. So now I am going to make a recursive call. So in the in order part, we will first have to traverse along the left subtree. So I'm going to pass the left pointer, and this is known as recursion. And we are recursing left part of the subtree first, then we will just display the data of the key, and after that we are going to call the in order function. But since in this time we are going to make it point to the right subtree, so we will use these two recursive functions to traverse to the left part and to the right part, and in between we are going to just display the root node. So first we will traverse along the left part, then the root, and then finally we are going to traverse to the right part, and this function will just display our whole tree. And after every line we are just going to write this end else statement. So this is a particular example of in order traversal, and we know that the result will just display, the output will be just in a sorted manner. So let's run this program and see its output. So you can see here that the output is the in order traversal and all the elements are in a sorted manner. So this is how we have implemented the in order traversal. In the pre-order and post-order traversal, we are just going to shuffle these three lines. So let's see what is the order in the pre-order. In the pre-order, we are just going to display the root first, then the left subtree, and then the right subtree. So this is the order. So we are going to change these three lines in case of the pre-order. So in case of pre-order, we will first display the roots key, then we will just call the recursive function pre-order, and this time we are going to pass the left pointer to this recursive function to recur left down the tree, and then similarly we are going to recur right down the tree. So in this way we can write the pre-order function, and similarly we can also write the post-order function, which says that first display the left node, then the right, and then, so this is right, I'm going to write it RI, and then the root node. So these are the orders. You've just shuffled these three lines and you can get these three orders. So let's see what will be the output in the case of the pre-order. So in the case of pre-order, first we will have to display the root. So the value of the root is 50. So I will write 50 here. So after that, it will just traverse along the left part of the tree and it will start displaying the root key, and then it will traverse along the right part of our binary search tree. So similarly we can also create the post order function. So in this manner we have implemented our example of a binary search tree, and in binary search tree we have created this insert function, and we have seen how we will have to insert a particular node using the recursion, which is an important topic and an important part of traversal in a binary search tree, because you will have to traverse along the left part or the right part. If you want to traverse along the left part, just call the same function again, but just point it to the left part using the left pointer. And if you want to do a recursive or recursion to the right part, just call it the right part. Just call it with a right pointer. So in this manner we have created the insert function, and we have also created these traversals, which are the in order, pre-order, and post-order traversals. And we have seen how the function we have created, we have again used the recursive methods to traverse along the left part of the subtree and along the right part of the binary search tree. So thanks for watching.